we already had two lectures of SH 102 in the past 2 weeks. So the lectures are recorded and shared, okay? You should be able to download the 2 previous lectures. I have just shared with you the recordings of the lecture last week. I was busy, otherwise I should have shared with you much earlier than that. But I also shared another video of a lecture on atomic structure, which you should download and interact with, okay? So let me start our lecture for today. So today we are going to have a lecture on structure. You remember what I have always been telling you? Structure of a chemical compound determines its property, whether it is physical property, chemical property, or biological property is determined by its structure. For example, the chemical structure you see on the board at the bottom is a chemical structure of the anti-cancer drug Gleevec, which we have talked about. If you change some of the groups on this molecule, if you replace this part with something else, it will no more be an anti-cancer drug. This part of the molecule, like any other part of the molecule, is what is responsible for its property, for the fact that it has got anti-cancer activity or property. So the property of a molecule is encoded in its structure. Structure determines properties. So if you want to understand the properties of molecules, whatever property of a molecule you are studying and trying to understand, you must have a clear understanding of its structure. So what we are going to learn in this coming few lecture is about the structure of molecules, starting from the atomic structure. You remember, in an atom, there are 3 fundamental subatomic particles: the protons, the electrons, and the neutrons. And the neutrons and the protons and the neutrons are found in the nucleus, and the electrons are found at different energy levels around the nucleus. So you have to understand the structure of the atom. You have to understand how particularly the electrons of an atom are arranged. You have to know how many electrons are available in the valence shell of a particular element. So you have to have an understanding of the structure of a molecule. So if you have an understanding of the structure of an atom, you can also figure out from that knowledge in what type of chemical bonding that particular molecule is involved in. Is it ionic bonding or chemical bonding? So once we have an understanding of the structure, the atomic structure, we'll study about chemical bonding. And as you know, the 2 major classification of chemical bonding are ionic bonding and covalent bonding. Depending on the atoms that are involved in chemical bonding, the bonding that exists between the element could be ionic or covalent. For example, as in the case of the simplest organic molecule, methane, CH4, there is a covalent bonding between the carbons and the hydrogens. So we'll have a review about chemical bonding. And then as we finish this section, we'll learn about chemical structure, how to draw the structure of molecules, just like the way the structure of Gleevec is drawn in here. So we'll learn about atomic structure, chemical bonding, and chemical structure. And then, as you now know by now, the university has adopted blended learning, meaning physical as well as online learning. And what I have done, please, yes? Hello? Hello? What are you saying? Hello? I have not heard what you are requesting. So let me continue with the class in the absence of that, because I have not heard anything. And what I have done, I have pre-recorded a video on atomic structure. So the lecture from slide 60 all the way to slide, let me just go. All these parts, I have pre-recorded it. Please mute your mic. Unless you are asking a question, please mute your mic. So I have a recording which I shared with you of a discussion going all the way from slide 60 to slide 74, almost a 2.5 hour recording I have shared with you. I want you to download it and listen to it, okay? Just like any lecture. And then we'll have a discussion on these in the form of assignment, tutorial classes, etc. So I will therefore start my class starting from slide 75. Okay? Now, in high school, you learned about chemical bonding, a bond that exists between two different elements. Elements form bonds with each other because they are not stable the way they are. So the reason why elements form chemical bonding between each other is to be converted from an unstable individual atoms to stable molecules. So formation of a chemical bond is an energetically favorable process from high energy, unstable species to stable, low energy species. So the reason why chemical bonds forms between two elements is because the process is energetically favorable. Okay? So, for example, even identical elements like hydrogen, oxygen, and nitrogen, these ones, they do not exist as individual atoms. Hydrogen does not exist as a hydrogen atom. Similarly, oxygen and nitrogen, they do not exist as individual atoms. Hydrogen exists as H2. Oxygen exists as O2. Nitrogen exists as N2. Chlorine exists as Cl2. They have formed chemical bonds with each other. In the case of hydrogen, there is a single bond that is formed between the two atoms. As a result of that single bond between the two hydrogen atoms, hydrogen H2 is a stable molecule compared to hydrogen itself. The same to oxygen. The two oxygen atoms have formed a double bond. The same to the nitrogen. The two nitrogen atoms in nitrogen molecule form a triple bond. So chemical bonding is formed between atoms because the way they are, the atoms are unstable. They have very high energy. As a result, they form chemical bonds with one another. The purpose of forming this chemical bonding with one another is says that they can become stable. It says that they can have low energy. So formation of a chemical bonding is an energetically favorable process. It is a process that takes unstable species into a stable species. So during formation of chemical bonding, as you know, the content of the nucleus are not involved. For example, when two hydrogen atoms form the molecule H2, the element still remains the same, whether as H as an atom or as hydrogen molecule, the hydrogen still remains. You cannot react two hydrogen atoms with one another and get oxygen. That will not happen. What this is basically telling us, during the formation of a chemical bond between two elements, the content of the nucleus, that means the protons and the neutrons, does not change. You remember, the atomic number is the number of protons in the nucleus of an atom. The atomic number will not change during formation of a chemical bond. What is going to change during formation of chemical bond is the arrangement of the electrons. It's not even all the electrons that's going to change, only the valence electrons. So during chemical bonding, the content of the nucleus, that is the protons and the neutrons, and the core share electrons, the inner share electrons, are not going to be involved. What is involved during formation of a chemical bond are only the valence electrons. So when a chemical bond is formed between two elements, as you've learned in high school, these valence electrons are either going to be transferred or shared. So the valence electrons are going to be either transferred or shared, and then as a result of this process, the molecule that is going to be formed will be stable. So the reason why the electrons are either going to be shared or transferred is to come up with an electron configuration of the noble gases, a stable octet of electronic configuration. Therefore, to achieve stability, when atoms form chemical bond with one another, they will either transfer the electrons or share the electrons. Whether the atoms will achieve their stability either through sharing of electrons or transfer of electrons will be dependent on the nature of the atoms that are involved in chemical bonding. For example, you remember sodium chloride, salt, chumvi, is an ionic compound. But if you take a molecule like methane, CH4 is a covalent compound. So whether we are going to have covalent bonding or ionic bonding between two atoms, that is going to be dependent on the nature of the atoms that are involved in chemical bonding. For example, if you take this situation, what I have on top, the cartoon is showing, on this side, you have an atom that is not happy, sodium, with a gloomy face. And then on this side, you have chlorine that is eyeing this electron, that is really inviting these electrons to come to it. If you remember from the electron configuration of the atoms which you've studied in high school, the electron configuration of sodium is 281. 281. Sodium has got one valence electron on its third shell. So if sodium could lose this one electron by giving it to another element like chlorine, the sodium will have the electron configuration of the corresponding noble gas neon 28. As a result, sodium will easily give up this electron, lose its electron. For example, if you look at sodium and it is valence electron, they are not even looking at each other. The sodium is looking away from the electron and is not happy about having this electron. And then even the electron is not looking towards the sodium, it is looking away, particularly is looking away towards the chlorine, which is really inviting it, telling it, come please. So what's going to happen? This chlorine is proposing to take away this electron. Then the sodium saying, yes. Hello? And the sodium is saying, just take him, please. And the chlorine will say, don't mind if I do. And then at the end of the day, this electron will be transferred.
I'm saying that I can't get.
Hello? What are you saying? Are you not seeing my slides?
Yes.
So let me reshare again. It's just because you have very bad network. That's the reason why
I'm not.
I've reshared again. Okay. Can you see my slides now?
Now it's dark.
Oh.
Anyone who is seeing my slides?
No, sir, we can't see.
Are you sure?
We can see now.
Yeah, because you will the ones who are not able to see is because you do not have very good network. Patrick Oteno, are you seeing my slides?
We are not seeing it.
I think you have denied access.
Huh? Patrick, can you see my slides?
No.
So let me stop sharing and reshare again. I've stopped sharing. Now I'm resharing again.
No, I can't see it.
How about now? It should be coming now to your screen. Hello? How about now?
Yes, sir.
Can you see it now?
Teacher, it is very dark. Yes, it's coming.
Let me wait for it to come. I don't know why it is taking long to reach you. How about now?
Hello.
I don't understand. Anyone who's seeing my slides?
We are seeing this.
Huh?
Screens. We are seeing it.
Yes, you know, it's just because some of you will not see it because you have a weak network.
Yeah, I can see.
Very clear, Cindy. Okay. So let me continue. Hopefully it will pick, okay? So at the end of the day, the electron from sodium will be transferred from the sodium to the chlorine. The sodium will lose its electron, chlorine will gain an electron. In the process, sodium will have a configuration of neon, which is 28, while chlorine will have a configuration of the corresponding noble gas argon 288. In the process, both of them, as a result of transfer of electron, managed to achieve the electron configuration of a noble gas. Both of them became stable. Okay? Now, it is not all the time that you can achieve such arrangement of electrons, arrangement of the noble gases through transfer of electrons. Sometimes it is required to share these electrons. For example, in this cartoon, you will see two ladies, Emily and Sarah. Both Emily and Sarah are feeling cold. They are shivering, but there is a blanket between them. If, please mute, remain muted. If because I can go to the setting and mute everyone. Okay, it is possible for me to do that, but I don't want to do such a thing. Okay. Yeah. So please remain muted. Otherwise, you'll be forcing me to go into the setting to mess up everything. So if Emily takes the blanket and puts it on, of course, Emily will feel warm, but Sarah will still remain cold, or vice versa. So in order for both of them to get comfortable, in this case, to be warm, they share the blanket. So to become stable, okay, molecules can share their electrons. So there are two ways of achieving stability, either through sharing of electrons or transfer of electrons, either through ionic bond, which is transfer of electrons, or covalent bonding, which is sharing of electrons. So chemical bonding, as I've told you, is an energetically beneficial interaction between atoms. It is an energetically favorable process because as a result of formation of a bond, either covalent bonding or ionic bonding, the atoms are going to have a stable, they are going to become stable, they are going to have low energy. So it is an energetically favorable process. So chemical bonding is an energetically beneficial interaction between atoms that requires them to maintain a specific distance from one another in space. So chemical bonding is what holds two atoms together. Like the two hydrogen atoms in hydrogen, they will remain glued to each other. They will bond to each other as a result of their electrons. And then when they form this chemical bond, they will be keeping a certain distance from one another. For example, if you have two hydrogen atoms, individual two hydrogen atoms, then just let us have a scenario of assuming or visualizing how these two hydrogen atoms can form a chemical bond with each other. You bring one hydrogen atom and another hydrogen atom, you bring them close to one another. The two hydrogen atoms are going to attract to each other because the nucleus of one hydrogen atom is positively charged, while the electron of the other hydrogen atom is negatively charged. Opposite charges attract to each other. So the two hydrogen atoms will attract to each other and will come very close, but they are not going to merge with one another, combine with one another, and become one. they will be keeping a certain distance from each other. The reason being, in addition to this attractive force, there is also a repulsive force. The nucleus of one atom will pull the nucleus of the other. The electron of one atom will pull the electrons of the other atom. As a result, they will reach a certain distance where the repulsive and the attractive forces are going to balance with one another. So chemical bonding is an energetically favorable interaction between atoms that requires them to maintain a specific distance from one another. So when chemical bond is formed between two atoms, that chemical bond is going to serve as a glue that holds these atoms together. So chemical bonds are the glue that hold molecules together. You are saying? Hello?
May you try to share your screen? I'm not seeing it at all now.
Let me try again. Okay, let me try again. Okay, I have stopped sharing. I'm sharing again. Let me do it for the last time. Okay, because on my side it is indicating that I'm sharing.
Excuse me,
I'm
sir.
on slide 76.
Excuse me.
Yes. Hello?
May you please tell someone to mute their videos? Tell some people to mute their videos. That may be the reason as to why they can't see the slide.
Okay, let me do something else. Okay, I don't know if the setting that I did, it may not allow you to unmute. And so chemical bonds are the glue that holds molecules together. So if you have any question or query, raise your hand, okay? Then I will allow you to unmute and say something, okay? And the glues that hold molecules together is a chemical bond. Then, as you can imagine, atoms are very, very small. Then they will be bonding to each other, and then they will have a certain distance between them. This distance they have between the two atoms is very, very small. It is very, very short. As a result of that, there is a special or a specific unit that is used for purpose of measuring the distance between atoms. For example, if you look at the distance between Nairobi and Nakuru, between Nairobi and Nakuru is about 150 kilometers. If I have to express this in terms of meters, the distance between Nakuru and Nairobi, I will say the distance between Nairobi and Nakuru is 150,000 meters. It does not make sense to have such a big number. That's why the 1,000, the 10th, the power of 3 is abbreviated as kilo. As a result, we can say the distance between Nairobi and Nakuru is 150 times 10 the power of 3 meters. And then 10 the power of 3 is nothing but a kilo. As a result, we say the distance between Nairobi and Nakuru is 150 kilometers. You remember there are distances that are measured in centimeter, distances that are measured in millimeters, distances that are measured in micrometers. So the distance between two atoms is measured in terms of angstrom unit. 1 angstrom unit is 10 the power of minus 10 meters. The reason why this is done, if you were to measure the distance between atoms in terms of meters, it will be 0.00000013 meters, for example. So instead of doing that, you can express the distance between two atoms in terms of angstrom unit, so that you can say the distance between the bond distance between two atoms is 100 angstrom units, meaning 100 times 10 to the power of minus 10 meters. So you'll frequently see distance between atoms expressed in terms of angstrom units. It is also common to see distance between atoms expressed in terms of nanometers. You can say the distance between the bond lengths between the two hydrogen atoms, the distance between the nuclei of the two hydrogen atoms in hydrogen, for example, you can say it is 120 nanometer, whatever value the distance is. Okay. So when you have a chemical bonding between two elements, like this element and this element have formed a chemical bond between each other, and then this chemical bonding that is formed between the two atoms is the net result of attractive and repulsive electrostatic forces. So let's just assume we have this atom. The black dot is its nucleus, where we have the positively charged protons and the neutral neutrons. And then the shaded part is the electrons. So we have this atom and these other atoms. When these atoms are brought close to one another, there is going to be an attractive force between the atoms, because the nucleus of one atom, which is positively charged, will attract the electrons of the other atom, which is negatively charged. So the protons of one will attract the electrons of the other. The proton of one will attract the electrons of the other. So there is going to be an attractive force between two atoms. So as a result of this attractive force, the two atoms that are going to be involved in chemical bonding will get close to one another. As they get close to one another, there is going to be also a repulsive force, because the two nuclei of the two atoms are positively charged. They repel with one another. Even the electrons of both atoms are also negatively charged. They will be repelling each other. So when atoms get close to one another, you will see one attractive force and two repulsive force. At the end of the day, the attractive force somehow outweighs the repulsive force. The atoms will get close to one another and get to each other and keep a certain distance from each other, called chemical bond. And then that is when the attractive and repulsive forces have balanced out. Okay, so the nucleus electron attractions, the nucleus electron attractions are greater than the nucleus repulsive and the electron repulsive forces, resulting in a net attractive force that holds the atoms together in a molecule. So it is as a result of this net attractive and repulsive forces, we'll have a chemical bonding forming between atoms, and then these atoms are not going to collapse into each other because of the repulsive forces. So at the end of the day, there will be a point where the balance between the attractive and the repulsive forces is maintained. When that happens, we'll have a chemical bond formed between the two atoms. And then there will be a certain distance between the two nuclei. And that nuclei will be the bond length. And then the length, the bond, this particular length called the bond length, is measured in terms of angstrom units. It is also common to see bond lengths between two atoms measured in terms of nanometer. Okay, so let me give you a review of chemical bonding, which you have studied in high school. You might have also studied some in SH 101, because to understand organic chemistry, we need to have a clear understanding of how bonds are formed between elements. And it is as a result of this bond formation between the elements, the structure of the molecule, which determines the properties, is defined. So to understand organic chemistry, it is necessary to have some understanding of the chemical bond, the forces that holds together, that holds atoms together within molecules. So the reason why bond is formed between an element, because as a result of the bond formation, there is going to be a stable arrangement of atoms. Then bonding, as you know, may occur between atoms of the same element, like for example, between two hydrogen atoms, or it can happen between different atoms, example, between carbon and oxygen. You can have a chemical bonding between identical atoms, as in the case of here, between two hydrogen atoms, or you can have a chemical bonding between two different elements, between carbon and oxygen, resulting in the formation of chemical bond between identical elements or between different elements. So bonding is a favorable process because it always leads to lowered energy and increased stability. When chemical bond is formed between two atoms, the molecule, the atoms, the species will be going from individual atoms, which are unstable, to a molecule where they are stable. So bonding is a favorable process because it always leads to lowered energy and increased stability. The reason why two atoms are going to form a chemical bond with one another is because they want to become stable. The way they are unstable. Okay, so when chemical bond is formed between two atoms, electrons are going to be shared or electrons are going to be transferred. So during the process of chemical bonding, the reason why chemical bond is formed in the first place, because through bonding, atoms are going to attain a complete outer shell of valence electrons. For example, if you take hydrogen, two hydrogen atoms form a bond with each other to form hydrogen molecule. Each of the hydrogens will be bringing one electron towards the formation of the chemical bond. As a result, between the two hydrogen atoms that are involved in chemical bonding, there are going to be two electrons that are equally shared between the two hydrogen atoms. So both hydrogen atoms will have two electrons. Since hydrogen is in the first shell, and the maximum number of electrons that is allowed in the first shell is 2 in hydrogen molecule, we have two electrons. Therefore, through bonding, the two hydrogen atoms, each of them attained a complete outer shell of valence electrons. So the whole purpose of forming a chemical bond is to have a complete outer shell of valence electrons. If you take elements like carbon, nitrogen, oxygen, fluorine, or any of the halogens, they form a chemical bond either through covalent bonding or ionic bonding, such that they can have 8 electrons, a complete outer shell of valence electrons. Alternatively, because the noble gases are in column 8A of the periodic table, and especially stable as atoms having filled share of valence electron, we can write this general rule that govern bonding as through bonding, atoms attain a stable noble gas configuration of atoms. So the reason why atoms are going to be involved in chemical bonding is to have a stable configuration of the noble gases, either to have 2 electrons, as in the case of helium, or 8 electrons, as in the case of the other noble gases of the periodic table. So if you take hydrogen, which is a first row element in the periodic table, hydrogen, when it forms a bond with another hydrogen atom, it will have 2 electrons. 2 electrons, just like the corresponding noble gas, helium. So the reason why 2 hydrogen atoms form a covalent bond between each other is to have the electron configuration of the corresponding noble gas, helium. However, the other elements, especially the second row element, like carbon, nitrogen, oxygen, and fluorine, they are going to be involved in chemical bonding, is because they want to have the electron configuration of the corresponding noble gas, neon, where we have a complete valence shell of electrons with 8 electrons. So the reason why hydrogen is involved in covalent bonding or in chemical bonding, it wants to have 2 electrons, a completely filled first shell. The reason why these other elements, carbon, nitrogen, oxygen, and fluorine, are going to be involved in chemical bonding is because they want to have 8 electrons. So for example, if you take carbon, it has got 4 electrons in its valence shell. To have octet of electrons, to have 8 electrons, it will need additional 4 electrons. It acquires these additional 4 electrons through covalent bonding. So carbon forms 4 bonds, and then through each of these 4 bonds, 1 electron is brought to the carbon together with its 4 electrons. These 4 electrons that come from hydrogen, for example, will give the carbon octet of electrons. Okay, so elements that behave in this manner are said to follow the octet rule. And there are 2 different types of, or 2 different kinds of bonding that exist between elements, as we have seen, or as you have learned in high school. And then these ones are called ionic bonding and covalent bonding. So elements, when they form a chemical bond, the reason why they want to have a the reason why they form a chemical bond is to have octet of electrons, 8 electrons in their valence shell. So some elements attain their octet of electrons by forming ionic bonding with each other, while some other elements attain this octet of electron by forming covalent bonding. Ionic bonding, which involves transfer of electrons, and covalent bonding, which involves sharing of electrons. So ionic bonds result from transfer of electrons from one element to another element, while covalent bonds result from the sharing of electrons between the 2 nuclei. So the chemical bonding that exists between atoms can be broadly classified as ionic bonding or covalent bonding. Whether it's going to be ionic bonding or covalent bonding, it depends on what is required to have octet of electrons. If electrons have to be transferred to have octet of electrons, the bonding is going to be ionic bonding. if electrons are going to be shared or have to be shared to have octet of electrons, the bonding will be covalent bonding. So you have to know how ionic bonding comes about and how covalent bonding comes about. So whether we are going to have covalent bonding or ionic bonding between two atoms, that is dependent or is determined by the location of the elements in the periodic table. For example, we know sodium chloride is an ionic compound. The bond between the sodium and the chlorine atoms is ionic bonding. The reason why the bonding between them is ionic bonding is because of their position in the periodic table. Sodium is on the extreme left of the periodic table, is in group 1. And then chlorine is in the extreme right of the periodic table. You remember the noble gases are not involved in any type of chemical bonding, in any type of meaningful chemical bonding. So we leave them out. So the two extremes are group 1 elements, group 1 element, and group 7A element. If there is a chemical bonding between group 1A element and group 7A element, that chemical bonding is ionic bonding. So the type of bonding is determined by the location of the elements in the periodic table. An ionic bond generally occurs when elements on the far left side of the periodic table, the group 1A element, combine with elements on the far right side, ignoring the noble gases, which form bonds rarely. So that's how ionic bonding is formed. Of course, during the process of ionic bonding, the element on the far left, like sodium, potassium, lithium, etc., they will lose electrons, and the element on the far right of the periodic table, like fluorine, chlorine, iodine, they will gain electrons. So one of the atoms that involved in chemical bonding will be positively charged, the other one will become negatively charged. So a positively charged cation formed from the element on the left side attracts a negatively charged anion formed from the left, from the element on the right side in the process, because of this strong electrostatic attraction between the positively charged ions and the negatively charged cations, anions. There is going to be a chemical bond that's going to be formed between the two atoms. Let's just see how a chemical bond is formed in the molecule of sodium chloride. You know, sodium chloride is an example of an ionic compound. How is this ionic bond between the sodium and the chlorine is formed when sodium chloride is formed? So if you take sodium, sodium is in group 1A of the periodic table. Its atomic number is 11, and its electron configuration, the way you've learned it in high school, is 281. It has got 1 valence electrons. To have octet of electrons, to have 8 electrons in its valence shell, sodium will find it easy to get rid of these electrons. So sodium, in order to have octet of electrons, it gives out its electron. So when it gives out electrons, it becomes Na plus. Then if you look at Na plus, its electron configuration is 2,8, just like that of neon. So the reason why sodium loses its electrons or gives up its electron in the valence shell, that 1 electron in its valence shell, is says that it can have the electron configuration of the corresponding noble gas, sodium, 8 valence neon, sorry, 8 valence electrons, just like that of neon. If you take chlorine, on the other hand, chlorine in its valence shell, it has got 7 electrons. Of course, to be 8, it just needs 1 additional electron. So remember, chlorine, its electron configuration is 287. It has got 17 electrons in a neutral chlorine, and this is how the 17 electrons are arranged. All the same, in the valence shell of chlorine, we have 7 electrons. To become 8, to have 8 electrons, says that it can have the electron configuration of the corresponding noble gas argon. It gains electrons. So the sodium loses 1 electron because the sodium will give up this 1 electron very easily, because when it gets rid of that electron, it will have the electron configuration of the noble gas neon. So the sodium gives up its electron, and then that electron will be picked by chlorine, because in the process, chlorine will have this electron configuration. It will have 8 electrons in its valence shell, just like that of argon. So now, during this process, when electrons are lost by the sodium and chlorine gains electron, ions are formed. Positively charged cation sodium ions and negatively charged anion chloride ions. So now these two, one is positively charged, the other one is negatively charged, and then there is going to be electrostatic attraction between sodium and chlorine ions, leading to the formation of sodium chloride, which is an ionic compound. So the reason why we have ionic bonding in sodium chloride is this is the easiest way. The transfer of electrons is the easiest way through which they can attain octet of electrons. Okay, so this you can read. So I sometimes share jokes during my class, and some of the jokes I'm not saying them for just for you to just laugh, but for you to learn something out of this. Let me tell you about this joke. 2 atoms are walking down the streets in Chiromo. 2 of them are walking down the streets from Chiromo to main campus. Then one atom says to the other atom, I think I have lost an electron. Then the other atom responds, are you sure? The first atom replies, I'm positive. To mean I'm sure. All the same, when atoms lose electron, they become positively charged. You remember during chemical bonding process, electrons are going to be gained or lost. When electrons are lost, a positive ion is formed. When electrons are gained, a negative ion is formed. You should not forget. This might look trivial, but I will test you in a short while or in subsequent lecture, and then since you forget this, you will tell me the charge that is formed in this particular atom as a bond is formed is positive when it has to be negative, or vice versa. So I just want you to remember, when atoms lose electron, when they use their electrons to form a bond with another atom, during this process, they are going to lose electrons. When they lose electron, they're going to become positively charged. And then when atoms gain electrons, they become negatively charged. Okay, so the first type of chemical bonding we have seen is ionic bonding. A bond that is resulted as a result of transfer of electrons. Then this ionic bonding is a chemical bonding that exists between atoms that are at the extreme end of the periodic table. Between extreme left and extreme right. When these atoms form a bond, the bond is going to be ionic bonding. Okay? But we have another type of chemical bonding called covalent bonding. And then covalent bonding occurs when atoms that are in the middle of the periodic table forms bond with each other. For example, when a bond is formed between carbon and oxygen, between carbon and nitrogen, such type of chemical bonding is called covalent bonding. So the second type of bonding, covalent bonding, occurs with elements like carbon in the middle of the periodic table, which would otherwise have to gain or lose several electrons to form an ion with a complete valence shell. For example, if you take carbon, it has got 4 electrons in its valence shell. The electron configuration of carbon is 2,4. So if carbon wants to have the electron configuration of helium, where there are only 2 electrons, the carbon has to lose 4 electrons. Or if it wants to have the electron configuration of neon, it has to gain 4 electrons. Losing 4 electrons or gaining 4 electrons is an energetically unfavorable process. It requires a lot of energy to lose or gain more than 2 electrons. As a result, such type of elements, when they are involved in chemical bonding, they do so through sharing of their electrons, because otherwise they have to lose or gain several electrons, which is not energetically favorable. So carbon, which is central to the study of organic chemistry, has 4 electrons in its valence shell, and then to have 4 octet of electrons, it will be sharing these electrons with other elements. So carbon, which is central to the study of organic chemistry, has 4 electrons in its valence shell. That's why we say carbon forms 4 bonds. That carbon is tetravalent. So using its 4 electrons in its valence shell, it forms covalent bond with other element. It can attain the electron configuration of neon by using each of these electrons along with 4 electrons from others, such as hydrogen, when it forms a covalent bond. So depending on the position of the elements that are involved in chemical bonding, the chemical bonding that exists between atoms could be ionic bonding or covalent bonding. If you have a chemical bonding between atoms that are in the middle of the periodic table, it is likely going to be covalent bonding. But between the extreme ends, it's going to be ionic bonding. Okay, so let's look at how the simplest organic compound, methane, is formed. The electron configuration of carbon is 2,4. It has got 4 electrons in its valence shell. And it is these 4 electrons that are in the valence shell that are involved in chemical bonding. The 2 electrons that are in the first shell are not going to be involved in any type of chemical bonding. They are closer to the nucleus, they are very stable. The ones that are going to be involved in chemical bonding are the ones that are furthest away from the nucleus, the valence electrons. So carbon has got these 4 electrons that can be involved in chemical bonding. And then hydrogen has 1 electron in its valence shell. So now there's going to be a chemical bond between carbon and hydrogen. The reason why they are going to react with one another, it says that each of them, the carbon as well as the 4 hydrogens will have or want to have octet of electrons. Okay, so when this molecule is formed, the 4 electrons, the ones shown in blue, are from hydrogen, while the ones shown in red are from, the blue ones are from carbon, and the ones shown in red are from hydrogen. Then after they have formed this covalent bonding, you'll see around the carbon we'll have 1, 2, 3, 4, 5, 6, 7, 8 electrons, octet of electrons around the carbon, just like the electron configuration of the corresponding noble gas, neon. Then if you look at hydrogen, across each hydrogens, around each of the hydrogens, we have 2 electrons. The electrons they came with when forming the chemical bond, and then the other electron with the share which they get from the carbon. So each of the hydrogens will have 2 electrons. So this means at the end of the day, carbon will have 8 electrons, just like neon, and then hydrogen will have 2 electrons, just like helium. Both of them will attain the electron configuration of the corresponding noble gases, forming a stable molecule. So, as you have seen, carbon forms 4 covalent bonds. Okay? And hydrogen forms 1 covalent bond. So the number of covalent bonds a particular atom will form will depend on its valence the additional number of electrons the element will require to have an electron configuration of the corresponding noble gases. So the number of covalent bonds an atom forms depends on how many additional valence electrons it needs to reach a noble gas configuration. For example, hydrogen has got 1 electron in its valence shell. To have the electron configuration of the corresponding noble gas helium, which has got 2 electrons, it needs additional 1 electron. As a result, hydrogen forms 1 bond. If you take carbon has got 4 electrons in its valence shell. To have octet of electrons, to have the electron configuration of the corresponding noble gas, it requires 4 additional electrons. As a result, carbon forms 4 bonds. If you look at oxygen is in group 6A of the periodic table. If you look at the electron configuration of oxygen is 2,6. It has got 6 electrons in its valence shell. In order to have octet of electrons, it needs additional 2 electrons, 6 plus 2 being 8. As a result, oxygen forms 2 bonds. The simplest example of an oxygen compound is H2O, water. In water, you have the oxygen forming 2 bonds with 2 hydrogens. Oxygen is divalent, meaning oxygen forms 2 bonds because to have octet of electrons, it needs 2 additional electrons. If you look at nitrogen, the simplest example of a nitrogen chemical compound you know from high school is ammonia, NH3, where the nitrogen has formed 3 bonds. Nitrogen is trivalent. Nitrogen forms 3 bonds. The reason why nitrogen forms 3 bonds, because in the outer valence shell, because nitrogen in its outer valence shell has 5 electrons. The electron configuration of nitrogen is 2,5. To have octet of electrons, it needs additional 3 electrons. As a result, nitrogen forms 3 bonds. So the number of covalent bonds a particular atom forms depends on how many additional valence electrons it needs to reach a noble gas configuration. Hydrogen atom has one valence electron. Its electron configuration is 1s. It will want to have the electron configuration of the corresponding noble gas helium, whose electron configuration is 1s2. It just needs one additional electron to have the configuration of helium. As a result, hydrogen forms one bond. If you take carbon, it has got 4 electrons in its valence shell. The valence shell of electrons are found in the S and P subshell. Its electron configuration is 2s2, 2p2, all the same in the second shell, in the outermost shell. Carbon has got 4 electrons. In order to have the electron configuration of the corresponding noble gas neon, which is s2p6, it needs additional 4 electrons. As a result, carbon forms 4 bonds, etc. The same applies to nitrogen. Nitrogen forms 3 bonds because it has 5 electrons in its valence shell. It needs additional 3. And the same is true the other element. Okay, now let's talk about bonding electrons and non-bonding electrons, or lone pair of electrons, in a short while. So let's look at some of the most important elements in the periodic table that are involved in covalent bonding with hydrogen, okay? I mean with carbon. These are hydrogen, carbon, nitrogen, oxygen, and the halogens. Now, if you take hydrogen, hydrogen has 1 electron in its valence shell. It wants to have the electron configuration of the corresponding noble gas helium. It has got 1. It needs only 1 additional electron to have 2 electrons. As a result, hydrogen forms 1 bond. You will not see hydrogen forming 3 bonds. You will not see hydrogen forming 4 bonds with other elements. It will make it unstable. Hydrogen forms only 4 bonds. Then if you look at carbon, carbon has got 4 electrons in its valence shell. And to have the electron configuration of the corresponding noble gas or octet of electrons, it needs 4 additional electrons. So that's why carbon forms 4 bonds to have those additional electrons. Then if you look at elements like nitrogen, oxygen, and the halogens, nitrogen is in group 5 of the periodic table. It has got 5 electrons. In order to have octet of electrons, it will need, in addition to these 5 electrons, additional 3 electrons. That's why nitrogen forms 3 bonds, as in the case of ammonia, NH3. Then if you look at oxygen, its electron configuration is 2,6. It has got 6 electrons in its valence shell. To have 8, it requires additional 2 electrons. That's why oxygen forms 2 bonds. Oxygen is divalent. The simplest example of an oxygen containing molecule is water, H2O, where the oxygen has formed 2 bonds. So nitrogen forms 3 bonds as a neutral molecule. Oxygen also forms 2 bonds as a neutral molecule. And then if you look at the halogens, they have 7 electrons in their valence shell. To have octet of electrons, they need 1 additional electron. Together with their 7 electrons, when 1 electron is added to them, they will have 8. So as a result, the halogens, fluorine, chlorine, bromine, iodine, etc., they form 1 bond. Okay, so you should know, because when you are drawing the chemical structure of an organic molecule, which determines its properties, you'll be writing the number of bonds a particular atom forms. Carbon forms four bonds, hydrogen forms one, halogens form one, oxygen forms two, and nitrogen forms 3 bonds. Now, what makes these elements, nitrogen, oxygen, and the halogens, the elements that are found further from the carbon, the nitrogen, oxygen, and fluorine, in addition to the electrons that are involved in chemical bonding, they also have electrons that are not involved in chemical bonding. So nitrogen will have 1 lone pair electron, which is not involved in chemical bonding. These 2 electrons, they are found sitting on the nitrogen. They are not involved in chemical bonding. So that's why they are called non-bonding electrons. If you look at oxygen, oxygen has got 1, 2, 3, 4 electrons, 2 lone pair of electrons that are not involved in chemical bonding as lone pairs. If you look at the halogens have 3 lone pair of electrons. Okay, so element let me just show here. Notice that when second row elements form fewer than 4 bonds, when they form fewer than 4 bonds, their octets consist of both bonding, that means the electrons that are shared, the electrons that are used in covalent bonding, and non-bonding or unshared electrons or lone pairs. So in these second row elements, carbon, nitrogen, oxygen, fluorine, etc., when they form fewer than 4 bonds, and when they form 3 bonds, when they form 2 bonds, when they form 1 bond, these elements, in addition to the electrons that are involved in covalent bonding, they also have lone pair of electrons. I'll try to explain this better in a short while. For example, let me see if I can unmute you so that if you can ask any question if you have any question. I have allowed you to unmute, and if you have any question, you can ask. For example, John Githuku, you've raised your hand. Do you have a question? Hello?
I don't have one.
Do you have one?
I don't have a question.
Okay, so lower your hand, okay? Huh? So just mute, okay? Mute, and let's have a discussion. Let's have a discussion, okay? And for example, if you take molecule of water, H2O, when you look at the oxygen in water, it has formed 2 bonds with hydrogen. Then each of the bonds will bring 2 electrons. So on the oxygen, you will see 4 electrons. 2 of each of the 2 electrons coming from as a result of the covalent bond the oxygen has with the hydrogen. So when you look at and count the electrons around the oxygen in water, you only see 4 electrons. But oxygen must have how many electrons to be stable? Hello?
8.
8 electrons. 4 of the electrons are the shared electrons. 4 of the electrons are the ones that are involved in covalent bonding. So the remaining 4 electrons are called non-bonding electrons. And these non-bonding electrons exist as a pair. So on oxygen of water, you'll have 2 lone pair of electrons, 4 electrons appearing as a pair. So it is together with these 4 electrons that you'll see 8 electrons in the oxygen atom in water, for example. If you take ammonia, in ammonia, how many bonds do you see the nitrogen forming? How many bonds does the nitrogen have in ammonia?
3.
3 bonds. The nitrogen forms 3 bonds with hydrogen. Then each of these bonds are as a result of how many electrons? A single bond is as a result of sharing of 1 electron from both atoms. So in a single bond, we have 2 electrons. So in ammonia, we have 3 nitrogen-hydrogen bonds. As a result of these 3 nitrogen-hydrogen bonds, we'll have 6 electrons around the nitrogen. But the nitrogen must have 8 electrons. How many additional electrons will the nitrogen need to have octet of electrons?
2.
So those two electrons will appear as lone pair. Okay. So let me mute all of you to avoid noise. Okay, like now I have muted you. I don't like muting students. I would like student to stop me anytime to ask a question. But some of you unmute for no good reason, creating a lot of echo, disturbing the class. Okay, please let us be disciplined and we only unmute when we have a question to ask, when we have a challenge. Okay. So now, this is just a cartoon on chemical bonding. There is this beautiful girl called neon, and there are so many atoms that are proposing to her. Aluminum is coming with its 3 electrons to form a bond with neon. Sodium is coming with 1 electron. Magnesium is coming with 2 electrons. Oxygen is coming with 2 electrons. Fluorine is coming with 1. Nitrogen is coming with 3 electrons. And then this beautiful girl called neon says, Taki, I don't need your electrons. I am happy the way I am. The message being, since neon is a noble gas, has octet of electrons, it is not involved in any type of chemical bonding. It does not either accept or lose electrons. They are not, as noble gases, they are not involved in chemical bonding. All the other elements in the periodic table, they are involved in chemical bonding in the first place to have the electron configuration of the noble gases like neon. So neon is saying stucky. So let me give you another story. This is a proposal by sodium to this beautiful girl called chlorine. And sodium, with 1 knee down, is giving his electron the way a boy gives a ring to a girl. And since, as you can see, since sodium and chlorine were lovers, and chlorine really did not reject this proposal, and she's happily receiving these electrons. So the sodium in this story is called natra, while chlorine is called chlora. So let me give you the story of this. Oh, it's you, Chlora. You look fantastic. I can give you my heart, but now take this present from me, this beautiful electron. And Chlora replies, oh, dear Natra, I love that. That adds to my look and happiness. Now, this ring of an electron makes our relationship reinforced, and we remain attracted to each other. Now, Chlora, this ring is my permanent present. The electron, remember, in ionic bonding is transferred from the sodium to the chlorine. It is permanently transferred from the sodium to the chlorine. That's why so Natra is saying, now Chlora, this ring is my permanent present. Unlike our organic friends, organic molecules are involved in covalent bonding. I will not make a claim for this ring by sharing it with you. It is yours forever. Ah, I know that. We, the inorganics, either give or take these electrons. Never do adopt a give and take policy like the organic friends. Not one more thing. Water is a good friend of us. You remember sodium chloride dissolves in water. Water is a good friend of us, and we can freely swim around, keeping our mutual love strong. That's nice, and thank you. Now will be known as sodium chloride. Okay, so this is a story about chemical bonding, but you can understand and relate to it very easily. So do you have any question on what I have discussed so far? You can unmute and ask. Okumu, you have raised your hand. Do you have a question? So in the absence of questions, let me continue further with it. Any of you can, Obiri, you have raised your hand. Do you have a question? Unmute and ask.
I have a question.
Please ask.
Yes, my question is,
Hello? I'm not hearing you. There is Olwatch who has raised his hand, and another one, I202407, who has raised the hand. You can unmute and ask question if you have any.
Excuse me, sir.
Yes.
I'm not getting your screen.
Why, my dear? Because I have been
I don't
sharing.
all alone.
I can see it is shared. Let me reshare it again. And I can see it is shared.
Yeah.
Can you see it now?
No.
Then you have a very weak network, my dear.
Excuse me, sir.
Yes.
I can see.
Now it is visible.
Excuse me.
Yes. Please ask. Leonard.
I think you should now update that slide because my screen shows that you are at slide 91, and I think you are moving to slide 93.
So I'm on slide 93. So it is taking some time for slide 93 to appear on your side. It's just, you know, there will be a delay if the network is not good. For example, if you have a weak network, you cannot watch a live match, you know, online. How about now? Has it reached there? Patrick, is it on slide 93 or?
It is in 92.
It is very sad, you know. It's supposed to sync so that we are in the same page, because I will be talking about something, you are saying something else, which does not make sense. Let me try it again. How about now?
Still loading.
We are together, we can continue.
Okay. And so what I have,
Okay.
we have discussed
slides.
Huh? Hello? So what I have discussed so far with you is about the atomic structure, which is covered in the video I have shared with you last week. Then we've talked about chemical bonding. Now we'll discuss about the third aspect, chemical structure. You remember what I told you? Structure determines properties. The property of a molecule is encoded in its structure. Let me just give you a simple example. If you take carbon as an element, it has a number of allotropes, okay? We know about two of the allotropes of carbon. One of them is graphite. The other one is diamond, okay? Two different substances. One of them is graphite, the other one is diamond. Both of them are carbon. You know what graphite is and what diamond is. Graphite conducts electricity, while diamond does not conduct electricity. Graphite is one of the weakest substance you can find, while diamond is probably the strongest substance. Both of them are carbon. Diamond is very, very beautiful. It's sought after, okay? While graphite is like charcoal, very cheap. Both of them are carbon. The difference between the diamond and the carbon is in their structure. The way the carbon atoms are joined to one another in graphite is different from the way the carbon atoms are joined to one another in diamond. The same molecule, different property. I mean, the same atom, different property. The reason why diamond and graphite have different property is because they have different structures, different chemical structure. So structure determines properties. So this molecule, this molecule I have on the slide is called oxytocin. Oxytocin is called the love chemical. Okay, it is called the cuddle chemical. It is involved in many things that are related to love. A boy loves a girl falls in love with a boy, and then because of the fact that this chemical is generated in the body, and you have that kind of feeling. This chemical compound is involved in relationship that exists between a mother and her child. That bond that exists between a mother and a child is as a result of such type of chemical. You remember, there are some mothers who get depressed and do not want to even to associate with their baby. They go into post-mortem, it's called post-depression, post-depression. This because this chemical compound is not generated. So this chemical compound serves as a bond between, that strong love that strong bond that is there between the mother and the child is as a result of such type of molecule. I want you to Google about oxytocin, the love chemical. You will find a lot of stories about relationship, etc. The reason why oxytocin acts as the love chemical is because of its chemical structure. Oxytocin is a peptide, is a protein, like a chain of amino acids. And then these are the amino acids are arranged. And then if you change any of the groups in here with another one, if you change even the arrangement of the atoms in this particular molecule, it will lose that particular property. So structure determines property, and it's very important as students of organic chemistry or as students of chemistry, as scientists who will apply chemistry one way or the other in their professional engagement, need to have a very good understanding of the structures of chemical compounds. So our next lecture, the subsequent lectures we are going to have, is going to be on chemical structure. So chemical structure is the key to everything in chemistry. The property of a substance depend on the atoms it contains, and not only that, and the way these atoms are connected. You remember in both diamond and graphite, the atom both diamond and graphite contain is carbon. It's the same, but the way the carbon atoms are connected to each other is different in diamond and graphite. As a result, diamond and graphite have different properties. So the property of a substance depends on the atom it contains and the way these atoms are connected to one another. So in this unit, we'll study about 3 important features of the structure of organic molecules. The first one we are going to study is the Lewis structure. So when you are studying the Lewis structure of an organic compound or any type of molecule, we are talking about which atom is next to which one. What kind of chemical bonding exists between 2 atoms? Is it double bond? Is it single bond? Is it triple bond? Does it have lone pair of electrons? If there are lone pair of electrons, on which atom are these lone pair of electrons? That's what we'll study when we study the Lewis structure. And then once we have studied about the Lewis structure and determined which atom is connected to which particular atom, in what type of chemical bonding, etc., then we study about hybridization. Then hybridization will tell us about the shape of molecules. The Lewis structure, as we'll study, you will see, does not give us any information about the shape of the molecule. If you want to know the shape of the molecule, we need to look at the hybridization of each of the atoms in the Lewis structure. Then we'll talk about the shape of the molecules after we are done with the Lewis structure. And then as we finish this unit, we'll talk about the spatial arrangement of atoms in a molecule, how the atoms are arranged in space, which is a concept of stereochemistry. We'll study stereochemistry, which tells us in which direction a particular atom is facing, how particular atom is arranged in space in relation to the other atoms. So for the structure of a molecule on which its property depends, it is determined by these 3, by the Lewis structure, by the hybridization, and by the stereochemistry. As a result, in this unit, we'll study about these 3 aspects of a structure of a molecule. So we'll start our study by looking at Lewis structure, the simplest form of drawing the structure of molecules, Lewis structure. So let me start by defining what Lewis structure is. So when you are asked or when you draw the Lewis structure, you are drawing a chemical structure in which all the electrons in the valence shell are shown as dots or as solid line. Is called Lewis structure. So when you are drawing the chemical structure of a molecule, you will be drawing the elements, the symbol for the elements, and then you'll use the valence electrons of all the atoms that are involved in that particular molecule. And then you use these valence electrons either as dots, 2 dots as you can see here, as a lone pair, or as solid lines. A solid line like this representing a chemical bond. So the Lewis structure will show us how the valence electrons are arranged among the atoms in a molecule. For example, when you form a molecule of water H2O, there's going to be a chemical bonding between the 2 hydrogens and the oxygen. And then when hydrogen and oxygen form a chemical bond with one another, the electrons that are going to be involved are only the valence electrons. So hydrogen has got one valence electron. So we have 2 hydrogens in water. The 2 hydrogens will contribute 2 valence electrons, 2. And then oxygen has got a valence electron of 8. The total valence electrons of water is 8. 2 of them coming from hydrogen, 6 of them coming from oxygen. So when you are writing the Lewis structure of a molecule of water, for example, you are just showing how these valence electrons, these 8 valence electrons coming from the 2 hydrogens and the oxygen, are arranged among the atoms, among the 2 hydrogens and the oxygen, as a molecule of water is formed. So we'll see how this one works. So a Lewis structure, when you draw the Lewis structure, it shows the symbol of the element, and then that symbol of the element is surrounded by a number of dots equal to the number of electrons in the outer shell of an atom of that particular element. For example, if you are writing the Lewis structure for carbon, for example, the element carbon, you write the symbol C. You write the symbol C, and then since carbon has got 4 valence electrons, there will be 4 dots around the carbon, and that will be the Lewis structure for carbon. So we only show the valence electrons, and then you put these valence electrons as dots around the atom. The symbol C will represent what is contained in the nucleus of carbon. The symbol C will represent the 6 protons that are there in the nucleus of carbon, as well as the 6 neutrons that are in the nucleus of the carbon. The symbol C also represents the inner shell electrons. You remember the electron configuration of carbon is 2-4. It has got 2 electrons in the inner shell and then 4 electrons in the outer shell. So when you write the symbol C, that symbol C represents what is contained in the nucleus, the protons and the neutrons, and then what is available in the inner shell. So then we show the valence electrons as dots. So a Lewis structure shows the symbol of an element surrounded by a number of dots equal to the number of electrons in the outer shell of an atom of that element. In Lewis structure, the atomic symbol, carbon C, for oxygen O, for hydrogen H, for sodium Na, the atomic symbol represent the core, that is the nucleus, where you have the protons and the neutrons, and then the inner shell electron. That's what the atomic symbol represent. We'll show the valence electrons as dots. So when you are writing or drawing the Lewis structure of a molecule, we follow 3 general rules as we write the Lewis structure of an organic molecule or an inorganic molecule. First, since the only things that are involved in chemical bonding are only the valence electrons, so we only show the valence electrons. We draw only the valence electrons. We involve only the valence electrons. So you have these valence electrons. And then there's going to be a chemical bond between the atoms that are involved in that particular molecule. So if you have second row elements like carbon, nitrogen, oxygen, fluorine, etc., when you are sharing these valence electrons, you make sure they only have octet of electrons, not more than 8 electrons. So the first thing is, the first rule is you only use the valence electrons. You don't count the other electrons because those other electrons are not involved in any type of chemical bonding. And then you share these valence electrons among the elements that are involved in chemical bonding. So when you are sharing these electrons among the elements that are involved in chemical bonding, you should not put more than electrons around atoms of in the second row of the periodic table, like around carbon, around nitrogen, around oxygen, around fluorine, like that, or among the halogens, around the halogens, you don't put more than 8 electrons. Because these elements, they get involved in chemical bonding, as we have talked about, to have octet of electrons. So they should not have more than 8 electrons. If it is a hydrogen, remember, when it's involved in chemical bonding, it wants to have the electron configuration of the corresponding noble gas, helium. And then helium has got 2 electrons. So give each hydrogen 2 electrons. So we're going to follow the octet rule, which we know. We're also going to follow the duet rule. The duet rule applies for hydrogen. Around the hydrogen, we can only have 2 electrons. Around the other elements like carbon, nitrogen, oxygen, and chlorine, fluorine, etc. Around this element, we put octet of electrons. So if you do that religiously and apply it all along, we'll have drawn the Lewis structure of an organic or a molecule in general. So when drawing a Lewis structure, make sure hydrogen atoms are surrounded by 2 electrons, and elements like carbon, oxygen, nitrogen, and the halogens, fluorine, chlorine, bromine, or iodine, these ones are surrounded by 8 electrons. So you must make sure the octet rule is obeyed for the carbon, oxygen, nitrogen, and the halogens, and the duet rule is obeyed for hydrogen. That's what we do. And then at the end of the day, we are going to follow some rules. So we have, when you do so, you have valence electrons that are going to be used in formation of a chemical bond. Those ones are called the shared electrons, but we are going to have also electrons that are not going to be shared. So we have two types of electrons, or 2 types of ways in which the valence electrons can be used. One way is in the formation of a bond between 2 elements. Those ones are called shared electrons. They are called bonding electrons. But there are electrons that are not involved in chemical bonding. These electrons are called non-bonding electrons, or lone pair of electrons, or simply lone pairs. So we're going to see all this. So skills in writing Lewis structure for molecules is fundamental to the understanding of organic chemistry in general. So you need to have very good skills in drawing the Lewis structure of molecules, and that's what we are going to do. Let me just give you, before we finish, a simple example of drawing the Lewis structure for hydrogen fluoride, HF. So when you are drawing the Lewis structure for HF, rule 1 says we must only involve the valence electrons. So we have hydrogen and fluorine, which are going to be, which are formed this HF molecule. Hydrogen has got 1 valence electron, fluorine has got 7 valence electrons. The total valence electrons we have are 8. So hydrogen has 1 valence electron and fluorine has 7 electrons. So we have these 8 electrons, which you are going to share between the hydrogen and the fluorine. As we do so, we must follow the duet rule for hydrogen. The hydrogen should only be surrounded by 2 electrons, and the octet rule for fluorine. So this is the Lewis structure for hydrogen, where we have 1 dot on the hydrogen representing the 1 valence electron of hydrogen. And then this is the Lewis structure for fluorine, where you have 7 electrons on the fluorine, okay? The 7 valence electrons. So these ones are going to form a covalent bond. To form a covalent bond, hydrogen will bring 1 electron, fluorine will bring 1 electron, and then those electrons will be used to form a bond between the hydrogen and fluorine. So when you look at this, you will see these 2 electrons, the one that are shown in blue, are the electrons that are shared between the hydrogen and fluorine. Then if you count the number of electrons around the hydrogen, are these 2 electrons. Then if you look at the number of electrons that are around the fluorine, are these electrons that are shown in blue, 1, 2, and then the electrons that are in red. So these ones are in total 6, 1, 2, 3, 4, 5, 6. So if you look at fluorine, in addition to these 6 electrons, which are on the fluorine itself, which are not involved in any type of chemical bonding, the lone pair of electrons, in addition to this lone pair of electrons, it has got these bonding electrons. So on the fluorine, we'll have 8 electrons. On the hydrogen, we'll have 2 electrons. 2 electrons around the hydrogen, 8 electrons around the fluorine. As a result, this is a valid Lewis structure for hydrogen fluoride. Of course, 2 dots representing a chemical bond are represented by a line like this. A line like this represents a chemical bond, and then this line is as a result of overlap of 2 electrons. So when you look at this, on the hydrogen, we have 2 electrons. Around the fluorine, we have octet of electrons. So as a result, this is a valid Lewis structure for fluorine. Then out of the electrons around the fluorine, the 3 of them, these ones are lone pair of electrons on fluorine. So when the valence electrons are used in formation of a chemical bond between 2 elements, some of these valence electrons will become shared electrons or bonding electrons, while the others become non-bonding or unshared pair of electrons. So we'll build up on this and go through the various steps of drawing the Lewis structure of a molecule. Okay. So I don't know if you have any questions. Let me allow you to unmute and ask. Okay. So you must learn how to draw the Lewis structure of molecules. Okay. It is not complicated. Okay. So one of the things we know, when drawing the Lewis structure, we only involve the valence electrons. Okay. For example, if you take a molecule of ammonia, NH3, hydrogen has got 1 valence electron. So we have 3 hydrogens, each of them bring 1 electron. So the valence electrons that's contributed by the hydrogen are 3. The nitrogen has got 5 valence electrons. So 5 valence electron from nitrogen, 3 valence electron from hydrogen, a total of 8 valence electrons. These are the electrons that are going to be used in formation of a bond between the 3 hydrogens and nitrogen. So when you are drawing the Lewis structure, you share these electrons between the 3 hydrogens and the nitrogen. When you do that, make sure there are only 2 electrons around the hydrogen, following the Dwight rule. Then you must also make sure there are 8 electrons around the nitrogen. So as you do so, some of the electrons will be bonding electrons, the other electrons will be non-bonding electrons, okay? So we are going to learn how to draw the Lewis structure of molecules. It's a skill you need to acquire, and with examples and with exercise, you will be in a position to draw the Lewis structure of any